titanium and its alloys have been indispensable in the aviation, medical, and energy-related industries for decades. Their popularity is due to a unique combination of lightweight, high strength, corrosion resistance, and biocompatibility. These properties make titanium a key material for the manufacture of implants, aircraft components, and 3D printed parts. The development of additive technologies, in particular, selective laser melting and electron beam sintering, requires a stable and homogeneous source of raw stuff, micropowders with precise parameters. The quality of such powder serves as a critical factor for physical and mechanical properties of the final product. However, the production of titanium micropowders with a high degree of dispersion, a homogeneous particle shape, and a stable chemical composition remains a technological challenge. The most common grinding methods, mechanical mills, pulverization, and plasma chemical methods, have a number of constraints. High power consumption, uneven particle size, the risk of oxidation during processing, and considerable wear and tear of working members. This results in excessive consumption of raw stuff and degraded quality of finished powder. Realizing these challenges, GlobeCore engineers proposed an alternative solution: the use of AVSp batch-type vortex layer machines for production of titanium micropowders. These machines create a highly efficient grinding medium due to the effect of a vortex layer of ferromagnetic elements in an alternating electromagnetic field. A dynamic zone with a high level of mechanical energy is formed inside the reaction chamber, which ensures high-rate grinding of titanium raw stuff down to a micro level, disaggregation of particles and disintegration of agglomerates, surface activation for powder to carry out further processes, for example sintering, or laser melting. The key advantages of using the AVSp vortex layer machines include the following: controlled particle size. High impact energy and high rate agitation ensure a narrow particle size distribution, which is of particular importance to 3D printing and medical devices. Reduced oxidation. Processing may occur in an inert medium, which prevents the formation of titanium oxides. Process speed. The desired dispersion degree can be achieved in a matter of minutes, which shortens the processing cycle. Cost effectiveness. Low power consumption, up to 9.5 kilowatts, and minimum maintenance costs. Versatility. Suitable for laboratory, research, and small-scale industrial production. These features make the AVSp vortex layer machine technology an effective alternative to conventional methods for production of titanium micropowders, especially in an environment where high precision, purity, and stability of powder properties are required. GlobeCore solutions reduce the production costs, as well as improve the quality of final products in the critical areas like aircraft engineering, implantology, and additive manufacturing of complex parts. And what solutions do you use for production of titanium micropowders? Share your experience in the comments section. More information on the GlobeCore technology and equipment for titanium grinding can be found by following the link in the first comment or visiting our website, www.globecore.com.